morning everyone, this is Shivani Agrawal. I am Assistant Professor in Department of Information Technology, Ajay Kumar Garg Engineering College, Ghaziabad. So today I am start the lecture on the Arithmetic Binary System Part 2. Previous video lecture of Arithmetic Binary System Part 1 we have to cover the complements, that is the R's complement. In this lecture we have to cover the topic is R minus 1's complement. So we in the previous video we have to cover the basic of the arithmetic addition, subtraction, multiplication, division, then the R's complement. But in this lecture I have covered the topic that is R minus 1's complement. Basically, what is R minus 1's complement? R minus 1's complement is the converted form of the R's complement, that is the number is converted in the form of R to the power n minus R to the power minus m minus capital N. This is the formula, R to the power n minus R to the power minus m minus capital N, where R is the radix, n is the number of integer digits and m is the number of fractions. This is additional from the R and R minus 1's complement. So this is number of fractional digits. This is m and n is the positive number. So let's take an example, that is find the n's complement of the given number 7453. So how we have to convert this number in the R minus 1's form? This is 9 means the radix is R, that is 10. So 10 minus 1, this is R minus 1, so it is 9's complement basically. So how we have to convert the number in the R minus 1's complement, that is basically the decimal number, that is 7453. So first we have to apply the formula on this particular number. So it is 10 to the power 4 because the fractional digits are 4. So it is 10 to the power 4 minus 10 to the power 0 because there is no fractional digit. So it is 0 minus the number is 7453. So it is basically 1000. This is 4 times 0 with 1 minus 1 minus 7453. So first we have to add this number is minus 1 because both the numbers are negative. So it is basically 7454. So it is 7454. So we have to just subtract this number with the 10 as a radix. So this is basically 10, 9, 9, 9. So it is 10 minus 4, that is 6, 9 minus 5, that is 4, 9 minus 4, that is 5, 9 minus 7, that is 2. So it is basically 2546. So 2546 is the answer. This is the 9's complement or R minus 1's complement of the number is 7453, where R is the basically 10. Now take the second example. This is find the 9's complement of the given number. This is the fractional question, fraction part. So it is 0.7863. So in this particular question, the integer part is 0 and the fractional part is 0.7863, means it is the 4 digits in the fractional part. So it is basically 10 to the power 0 minus 10 to the power minus 4 minus 0.8763. So it is 10 to the power 0 is 1 minus 10 to the minus 4, that is 0.0001. So it is 0.0001 minus 0.7863. So how we have to convert this number and how we have to subtract this number? So it is basically we have to add this number with the 0.7863 is add with 0.0001. So it is 0.7864. So basically the number is 1.0000 because the fraction part is in 4 digits and 0.7864. So just subtract this number. So it is basically 10, it is 9, 9, 9. So it is 6, it is 3, it is 1, it is 2. So it is 0.2136. So this is the answer. So this is the R minus 1's complement form. Now take the next example with the complement of the 7's complement. It means the radix is 8. This is the octal number. So the number is 3675. So first we have to convert this number with the formula of R to the power n minus R to the power minus m minus capital N. So it is basically, that is what? That is 7 to the power 0, basically it is 8. So it is 7 to the power 4 minus, because the fractional is 0 and the integer is 4 bits. 10 to the power 0 minus 3675. So it is like that. It is the 1 4 times 0 minus 1 minus 3675. So we have to add 3675 plus 1. So it is basically 3676. Now we have to subtract this number with the 1 4 times 0. So we have to subtract, but after at the time of subtraction, how we have to take the carry part or the borrow part. So we take the borrow like as the r. So it is 8. So it is just we have to do it 1 0 0 0 0 3 6 7 5. So just we have to subtract this number if the radius is 8, because r is 8 in this the question. So it is 8 is here, 7 7 7. So it is 8 minus 5, that is 3, that is 8 minus 8 minus 5, it is 3676 है ना. So it is 8 minus 6, that is 2, 7 minus 7, that is 0, 7 minus 6, that is 1, 7 minus 3, that is 7 minus 3, that is 4. So it is 4102 is the answer. Now the next question is, find the 15th complement of the given number if the question is 7b.a. So first we have to convert this number with the r minus 1's complement form. So it is basically r to the power n minus r to the power minus m minus capital N. So it is basically 16 to the power 2 minus 16 to the power minus 1 minus 7b.a. So it is the after the conversion, it is 100 minus 0.1 minus 7b.a. So first we have to add this number 7b.b. So it is 100.0 7b.b. So we have to subtract this. This is basically 16. This is 15. This is 15. That I already explained how we have to do this. So it's 16 minus b. B is basically a is 10, b is 11. So it is basically 16 minus 11, that is 5. 15 minus 11, that is 4. And 15 minus 7, that is 8. So it is 84.5. So this is the answer. So these are the rules of the r's complement form. Now the next topic that is very important, that is exam time, the examination has the question on this particular topic. So it is addition oblique subtraction by using r's complement. So how we have to do this? So first we have to know about the rules of the subtraction. So rules for subtraction with the r's complement. First we have to take the r's complement subtraction. So first equate the number of digits of minuend and the subtrahend part. This is represented by m and s. If they are not equal, then we have to add 0. Add 0 at which part? At the MSB part. Add 0 with the MSB part and make the numbers equal. Find the r's complement of the subtrahend part, not the minuend part. Find the r's complement of the subtrahend part. This is apply for all the questions of the subtraction or with the r's complement. So first we take the r's complement of the subtrahend part, then add the minuend with the r's complement of the subtrahend. Okay. So these are the basic rules. So let's take the question. This is the question, and the last rule is that if the sum produce an end around carry, so discard this carry. If it is not produce any carry, it means after the addition, if the sum produce carry, then we have to discard this carry. If the sum not produce any carry, then take the r's complement of the result and put the negative sign in front of it. So how we have to solve this question? Let's take an example. So this is 76532 minus 4250 using 10's complement. So this is basically minuend part. This is the subtrahend part. Okay, this is m, this is s. Now this is the form of m minus s, like that. Okay. So first we have to equate the digits. So these are 1, 2, 3, 4, 5, and these digits are 1, 2, 3, 4. So first we have to equate the digit. So we put the 0 at the MSB part. So we put 0 on this is MSB part. So it is 0. Put here. So it is 0, 4, 2, 5, 0. Now first rule is clear, that is we have to equate the digits. Now we have to take the r's complement of the subtrahend part. Now we take the r's complement of that. So it is it is basically the tens complement of that. So, what is the formula we have to apply? That is r to the power n minus capital N. So, it is 10 to the power 5 minus 04250. So, it is basically 1 5 times 0 minus 04250. So, it is 95750. It is same like the r's complement rule. So, it is 95750. So, this is the final complement of that particular number. Now, we have to add this number with the minuend part. So, we have to add this number with the minuend part, that is 76532, add 95750, that is 2 plus 0, that is 2, 5 plus 3, that is 8, 7 plus 5, that is 12, so 2 is there, 1 is carry. Now, 6 plus 6, that is 12, again 1 is carry. Now, 7 plus 1, that is 8, 8 plus 9, that is 17. So, 1 is discarded from this carry. So, this is the complete, if the sum produce any carry, then we have to discard this carry. But now takes an example when we don't have any, the sum produce any carry. So, let's take a second example. This is what? 236.43 minus 542.3.43. So, first we have to equate the number. This is in the minor and the subtrahend type, and the complement is the 8's complement. So, first we have to equate the digits. So, it is basically 0236.43 minus 5423.43. Now, we take the complement of the subtrahend part. So, we take the complement of this particular number. This is the subtrahend. So, let's keep in mind, this is not the tens complement, this is the 8's complement. So, how we have to solve that? So, this is basically 1000 minus let's put in that 5423.43, right? This is basically 00. So, this is 8, this is 7, this is 7, this is 7, this is 7, this is 7. So, 8 minus 3, that is 5, 7 minus 4, that is 3, 7 minus 3, that is 4, 7 minus 2, that is 5, 7 minus 4, that is 3, 7 minus 5, that is 2. So, it is 2354.35. Now, this complement formed number add with the minuend. So, it is 0236.43. So, it is 0236.43. So, we add 5 plus 3, that is 8, but 8, this is very important thing. If the number produces with the same as the radix or the increase of the number with the radix, so we find the number with the same base form. So, if it is 5 plus 3, that is 8. So, basically it is 0, because when the decimal number 8 divided by 8, so it is basically 10. So, it is basically 10. So, it is 0, carry 1. Now, 4 plus 3, 7 plus 1, 8. So, again 8 produces. So, it is basically 10. It is 0, carry 1. Now, 6 plus 4, that is 10 plus 1, 11. So, if we divide 8 with 11, so it is 8, 1 is 8, and after the subtraction, this is 3 is that. So, this is basically is what? 3 is there, 1 is carry. Now, 5 plus 3, that is 8 plus 1, 9. So, it is basically 11. Sorry, it is basically 11. So, it is 1 here and 1 is carry. Now, 3 plus 2, that is 5 plus 1, 6. 6 is there because it is less than 8. And 2 plus 0, that is 2. So, the resultant is 2613.00. So, after the addition or the addition produced with the minor and the subtrahend, r's complement of the subtrahend, so there is no carry produces. If there is no carry produces, then takes the r's complement of this, the resultant value, and put the negative sign in front of it. So, it is basically 2613.00. Now, again takes the r's complement. So, it is basically r to the power n minus capital N. So, it is 4-bit number. So, it is 10 to the power 4 minus 2613.00. So, it is again 100 0 0 2 6 1 3. Now subtract this number, so it is basically 8 7 7 7. So 8 minus 3, 8 minus 3, that is 5, 7 minus 8, that is 6, 7 minus 6, that is 1, 7 minus 2, that is 5. So it is 5165.00. The resultant is 5165.00, but put the negative sign in front of it. So it is minus 5165.00. So it is the answer. So this is very important question, because in this question there are two basic things that you always keep in your mind. First, when the resultant bits after takes the complement of the subtrahend part, so the resultant bit, if the resultant bit is equal or increase with the radix part, so we take the value is in same base of that particular radix. So this is basically decimal part. So we have to convert the number with the same radix form. So this is the way that how we have to find the number with the same radix form. And after the resultant is came, then we have to convert. If there is no carry produces, then we have to take the r's complement of that particular number and put the negative sign in front of it. So this question is very important if we do the subtraction by using the r's complement. So this is the topic that we have to cover. Now, subtraction by using r minus 1's complement. So these are the rules. These are the rules same like the r's complement rule, but there is some minor differences over there. First is equate the digits. Then we have to put the 0 if the digits are not equal in the place of the MSB, and find the r minus 1's complement of the subtrahend part and then add with the minor. This is same like that. Now, if the sum produces an end around carry, this is a very important point. If the sum produces an around carry, so add this carry, not discard this carry. So add this carry to the LSB of the sum, and if it is not produced, then take the r minus 1's complement to the resultant and put the negative sign in front of the resultant. Okay. So let's take an example. So this is the question, that is 76532 minus 4250 by using 9's complement, that is the r minus 1's. Basically it is 10 minus 1 complement form. So first we have to equate the digits. So we have to equate the digits, that is 76532 minus 420. So first we have to equate, that is put the 0 in the MSB part of the subtrahend and find the r minus 1's complement of the subtrahend. So take the r minus 1's complement of the subtrahend part and find out the answer. So it is basically 95749. So we have to add this number with the minor part. So we have to add this number with 76532. So after the addition, the resultant produce the carry. Okay. So this carry is add with the LSB of the resultant. So it is basically 72282 is the resultant and 1 is the 1 produces 72281 is the resultant and 1 is the carry. This carry we have to add with the LSB of the resultant. So this is basically 1 plus 1, that is 2. So it is 72282. So this is the answer. Okay. So this is always keep on mind that we have to add the discarded carry, add that produces carry, not discard the carry. So this is the r minus 1's complement subtraction. Now these are the number representations. These are the sign magnitude and sign 1's complement, sign 2's complement form. So sign magnitude number representation is same as converted the number with the from the decimal to binary. So how we have to represent the number? If the number sign is positive, then we put the 0 as a plus sign. When the sign is negative, so we put the 1 as a negative number. So for example, if the plus 8, so the magnitude, so number represent 8 is 1,000,000, so it is the number representation from decimal to binary, and the sign representation, because it is positive, so it is 0. So it is basically 0, 1, 000. So this is the sign magnitude form. Now these are the other example of the sign magnitude representation. If the number is 48 and the second number is 13, but there is the negative sign, that is minus 13. So this is the sign bit, that is 0 because the number is positive, and this is the binary representation form of the 48 number. Now this is 13 and number represented in the 8 bit, so the number is in 8 bit form and the negative sign put as a 1. There is no 0 because the number is negative. So this is the simple sign magnitude form representation. Now the sign 1's complement form, if the number is positive, so it is same as the sign magnitude form, but if the number is the negative in the sign magnitude 1's complement form, so first we have to convert this number and takes the 1's complement of that particular number. So this is plus 48 and the minus 13. So first we have to convert the number plus 48 in the binary form. So it is basically 0 and this is the binary form of the 48. So it is the same as the sign magnitude form. If the number is positive, so it is completely same as the sign magnitude form. But if the number is negative, so first we have to convert this number in the binary, then we take the 1's complement of that particular number. So first we have to convert this number in the simply sign magnitude form, then we have to convert this number in the 1's complement of that particular number. So if the number is 0, 0, 0, 0, 1, 1, 0, 1, so we have to convert this number in the 1's complement form. So just take the complement of each bit. So if it is 1, then convert it is 0. If it is 0, then convert it is 1. So this is the signed 1's complement form. Now the sign 2's complement representation, if the number is positive, this rule is same with the sign 1's complement of the sign 2's complement form. If the number is positive, then the number is simply represent as the sign magnitude form. But if the number is negative in the sign 2's complement representation form, so first we have to convert the number. Suppose the example is minus 13. No, so first we have to take the binary form of the plus 13, and then we have to convert the number from first 1's complement form, then we have to convert the number of the 2's complement form. So this is the basic rule. So let's take an example of minus 13. First we have to write plus 13 in the binary form. This is the sign magnitude form. Then we have to convert the number. So take the 1's complement of that particular number. So just 0 to 1, 1 to 0. Then add 1 in the LSB of that 1's complement form number. So this is the 2's complement of the number. So these are the complete representation of the signed numbers. So thank you for this particular lecture. I think it is very visualized to you guys. Thank you.